Hello everyone, my name is Shanvi Chauhan and a very warm welcome to a lecture series of Principle of Electronic Communication. Uh, in this series, we are learning Unit 3 of Principle of Electronic Communication subject, which is in semester 3, Gujarat Technological University. Uh, in chapter 3 already what we have seen is characteristic of radio receiver, sensitivity, selectivity, fidelity, image, frequency, rejection. These are four main characteristic of radio receiver. Next we have learned block diagram of super heterodyne receiver, and we understood what is super heterodyne receiver and how it works. Amplitude modulated and frequency modulated signals need to be detected at receiver side. So envelope detector method was used. In fact, it is used in amplitude modulation. Amplitude modulated to recover the amplitude modulated signal. So we learned that envelope detector method using diode. Then we understood the demodulations of frequency modulated signal, and what are the techniques used. We understood that slope detection, balanced slope detection, phase discriminator, and balanced ratio detector. These were the four main techniques we have seen till date. The slope detection technique is the basic technique, and from that we derived balanced slope detection. Then to recover uh, the demerits of balanced slope detector, we understood phase discriminator and also balanced ratio detector. Balanced ratio detector was more efficient than phase discriminator, but still any one of these four techniques is generally used at the receiver side to recover the signal which was frequency modulated. Now let's go to FM receiver block diagram topic. This is topic number 3.5. Let's see what is the FM receiver block diagram. See, here FM receiver block diagram is shown. In FM receiver block diagram, the basic thing at receiver is we need to have an antenna. Here you can see the antenna is shown at the top of the diagram, and in which the arrow is denoted downwards. This arrow shows that signal was received by the antenna, and then it is fed to the next block, which is RF amplifier. Then the signal was processed at RF amplifier, and then it is given to a mixer. At mixer, a frequency from local oscillator, a signal with from local oscillator is mixed with a mixture, and the output of the mixture is given to the IF amplifier. Now this IF amplifier gives the output to limiter, and limiter gives output to discriminator. Then discriminator gives the output to the de-emphasis circuit, and then the de-emphasis circuit fed uh, uh, its output to AF and power amplifiers, and after that the audio signal is given to a speaker, and speaker gives the amplified output. Let's see the details of this block diagram. Now the FM receiver is also a super heterodyne receiver, and the FM receiver block diagram shown in figure 6.28 here shows just how similar it is to an AM receiver. The basic differences here are as follows. See, what are the basic differences? The AM receiver block diagram and FM receiver block diagram are almost same. And let's see what are the basic differences. Generally, FM has much higher frequencies. FM operates on much higher frequency. This is the first basic difference. Also, frequency modulators and demodulators need for limiting and de-emphasis in FM. And we will see next what is limiting and de-emphasis. It is also totally different method of demodulation. There are basically 4 different demodulation techniques we already have seen. So anyone from this 4 method can be used. Also automatic gain control. See here there is word AGC. Here you can see this automatic gain control technique is also used. It is also used in amplitude modulation. So for automatic gain control also there are different methods can be used. So these are the 4 basic differences from AM receiver. In AM receiver only by one method automatic gain control has been done, but here in FM receiver block diagram different methods are used to obtain automatic gain control. A number of sections of the FM receiver correspond exactly to those of other receivers already discussed. We have discussed already different receivers. FM receiver also have the same sections at receiver side. The same criteria apply in the selection of the intermediate frequency. Intermediate frequency need to be selected, so the same criteria applies in the selection of intermediate frequency. And IF amplifiers are basically similar. And a number of concepts have very similar meanings, so that only the differences and the spatial applications need to be pointed out. So we will discuss here only the different topics here which are different from AM receivers. Otherwise FM receiver works similarly as AM receiver. So let's see what the first block RF amplifier does. An RF amplifier is always used in an FM receiver because we deal with radio frequencies, high radio frequencies. So RF amplifier is always used in FM receiver. Its main purpose is to reduce the noise figure. Noise figure is a measure of the noise which is coming with the signal received. So the main purpose of RF amplifier is to reduce the noise figure, which could otherwise be a problem. Why? Because FM always needs large bandwidth. So it reduces the noise which comes with the signal. Why? Because FM has very large bandwidth, so the noise also is very high. It is also required to match the input impedance of the receiver to that of the antenna. So when the signal is coming from the antenna, the input impedance is also need to be required to match. So to match the input impedance, what is required? The grounded gate or cascaded amplifier is need to be there. Grounded gate means the gate and base of BJTs and FETs. Okay, so an FET or BJT needs with the gate grounded, or you can ground the base of transistor, and that can be employed in the RF amplifier circuit, or a cascaded amplifier need to be there to match the input impedance of antenna with the RF amplifier. Both types have the property of low input impedance and matching the antenna. So that's why we use generally grounded gate or grounded base or cascaded amplifiers. And employing this grounded gate, grounded base, and cascaded amplifiers, it doesn't need neutralization. So for impedance matching of the antenna, this is the best thing. And why it doesn't neutralize other requirements? Because the input electrode is grounded on either type of amplifier, effectively isolating input from the output. Now let's see a typical FET grounded gate RF amplifier is shown here in figure 6.29. It has all the good points mentioned and added features of low distortions and simple operation. This is just for your information how an antenna is given to transformer, and then grounded gate circuit has been introduced, and whatever the output we get from this circuit, it is given to the mixture, and at mixture frequency is generated from local oscillator and mixed with the output of this grounded gate FET-RF amplifier, and mixing this RF amplifier output with the local oscillator output at mixture, which is called super heterodyne principle. What we will get a frequency which will be called intermediate frequency, and it is given as an input to intermediate frequency amplifier. The oscillator circuit takes any of the usual form. The oscillators here are used Colpitts and Clap predominantly, and these are generally suited for very high frequency operation. Now tracking is not normally much of the problem in FM broadcast receiver. This is because the tuning frequency range is only 1.25:1, much less than in AM broadcasting. So a very satisfactory arrangement for the front end of FM receiver consists of FETs for the RF amplifier and mixture, and a bipolar transistor oscillator. As implied by this statement, the separately excited oscillators are normally used with some basic arrangements. Now let's see what happens at intermediate frequency amplifier. Whatever I am teaching you is everything given here in this slide. I will share this slide with you once the chapter will be completed. Now let's see what intermediate frequency and intermediate amplifiers can do. You can always have that diagram drawn in your notebook. You can draw the diagram in your notebook and you can learn one by one from this PPT. Again, the types and operation do not differ much from their AM counterparts. Means the operation and types of intermediate frequency amplifier is not different from AM. It is similar to AM. The intermediate frequency and the bandwidth required are far higher than in AM broadcast receiver. Here the frequencies are very high. Typically these frequencies are 88 to 108 megahertz and the intermediate frequency is 10 megahertz and the bandwidth is of 200 kilohertz. Okay, so the bandwidth of FM signals is 200 kilohertz, intermediate frequency of 10.7 megahertz, and the band is 88 megahertz to 108 megahertz. Now here the bandwidth is very large, so the gain per stage may be low. Okay, after that let's see what are the blocks at the FM receiver block diagram. There is something automatic gain control here at the receiver side, which we will study later on. A limiter circuit, which will be also covered later on. Then there is a discriminator circuit. We already understood this discriminator in FM detector techniques. Phase discriminator, you remember that? So discriminator we have already studied. A de-emphasis network and then AF and power amplifiers. This de-emphasis networks also we will learn later on. Okay, so now let's move to the next topic, which is communication receiver, in which a double conversion principle is used. Its main function is the reception of signals under used for communications rather than for entertainment. So when basic important communication comes into the picture, this communication receiver is used, in which the double conversion principle is the main important. It is a radio receiver designed to perform the task of low and high frequency reception much better than the type of set found in average households. This makes the communication receiver very useful in other applications such as detection of signal for high frequency impedance bridges. Now generally it is used virtually as a high sensitivity tuned voltmeters. Now signal strength measurement also uses this double conversion method, and frequency measurements and even the detection and display of individual components of high frequency waves. In this application the double conversion method is used. Now see, this is the block diagram of communication receiver. Again antenna receives the signal. There is an antenna coupling unit. We learned this unit in the previous topic, FM demodulation block diagram, in which a grounded gate or grounded base circuit is used or cascaded amplifier is used. Here the RF amplifier has fixed range 2 to 16 megahertz. Then it is fed to a first mixer where The local oscillator generates 3.7 to 17.7 megahertz, and it is mixed with first mixture. The output of first mixture is sent to first stage IF amplifier 1.7 megahertz. It is tuned to 1.7 megahertz. Here you can see there is a typing mistake in a book. It is written stage IF amplifier. It is not two stage or second stage amplifier. It is first stage IF amplifier. So whenever you write down this diagram in your notebook, or you remember this thing in your exam, remember it as first stage and not second stage. The output of this block is given to the second mixture. Again, a crystal oscillator is used. The crystal oscillator is tuned to 1.5 megahertz. A signal from first stage IF amplifier and this crystal oscillator both are mixed with here in second mixture, and the output of the second mixture is given to the second stage IF amplifier, which is tuned to 200 kilohertz. Now a bit frequency oscillator gives an output, and which is mixed here at the IF amplifier, and the output of the signal is given to the automatic gain control amplifier and also to the detector to demodulate the output. Now this detector output is given to the squelch circuit. This will also we learn in next topics. The squelch circuit's output is given to the audio amplifier, and it is again given to the power amplifier. Power amplifier boosts the signal and gives it to the speaker so that we can listen to the signal. These are generally used in voice modulations and demodulations. See, this slide gives us the basic idea how communication receivers looks. This is very old communication receivers. Nowadays this kind of communication receivers doesn't come, but this is just to give an idea that how old communication receivers were looking. Sorry, I forgot to slide the slide. See, this is the basic photograph, the first basic photograph of communication receivers. In old times, this kind of communication receivers were used. You can see here. This photograph is from Racal Electronics Private Limited. Okay. You can see here there are some remote control switches, some continuous tuning control main dial where you can see the frequency numbers, subsidiary dial where you can change operating modes, bandwidths and fault status. You can see some display there, what is the operating mode, what is the bandwidth. Okay, there are operating mode controls. Loudspeaker is also there so that you can hear the demodulated signal. Some channel scan is also there. A push button control for channel frequency selection and storage are also there. So this is a good communication receiver, though it was used in old times, but this was a good one. Now let's see the working of communication receiver. The receiving antenna intercepts the electromagnetic radiations and converts them into RF voltage. इसका मतलब ये है कि रिसीविंग एंटेना इलेक्ट्रोमैग्नेटिक रेडिएशंस को रिसीव करके समझ के उसको कन्वर्ट करता है आरएफ वोल्टेज में. The RF signal is then applied to RF amplifier through the antenna coupling network. अगेन हमने देखा आगे की FM डिमॉड्यूलेशन ब्लॉक डायग्राम में, वहाँ पे इम्पेडेंस मैचिंग वाज वेरी मच इम्पॉर्टेंट. देन दिस आर antenna coupling network is nothing but to match the impedance of antenna and the RF amplifier. The RF stage amplifiers, the first stage and second stage amplifies the signal which lies in the frequency range of 2 to 30 megahertz. The amplified signal is then fed to the first mixture in order to be mixed with the locally generated signal. The frequency of the local oscillator is 650 kilohertz above the frequency the receiver signal. Now the first local oscillator and the RF amplifier are ganged together to generate the correct oscillator frequency. The mixer stage generates an intermediate frequency signal at frequency of 650 kilohertz. The IF signal is then amplified by the first IF amplifier, and after this the signal is fed to the second mixture, which mixes the signal with another locally generated signal. The crystal oscillator at second stage is 1.5 megahertz. At the first stage it was 3.7 to 17.7 megahertz. Now the second local oscillator frequency is fixed at 500 kilohertz. Therefore, a crystal oscillator is used here to have good frequency stability. The second mixture generates the second intermediate frequency signal, and the value of the second intermediate frequency is 150 kilohertz. Difference between the first IF, which is 650, and the second local oscillator frequency 500 kilohertz. So the second intermediate frequency generates 150. Why? Because it is the difference from first IF and the local frequency. Now the second IF frequency is put below the normal intermediate frequency, which is for 55 kilohertz of the AM receiver. The first IF signal frequency is above 455 kilohertz up to a value of 650 kilohertz. Due to this arrangement, the communication receiver has the benefit of low and high IF frequency. So this mechanism of using two frequencies is known as double conversion. Okay. So here the difference is used, that's why it is called double conversion. The second IF signal is amplified using the IF amplifier stages again to the required value. Now after this, the detector circuit demodulates the received signal to produce an audio signal. This audio signal is then amplified by the audio driver amplifier and the audio output power amplifier, and the audio signal is given to the speaker to produce the sound output. Now automatic gain control is amplitude. Automatic gain control is employed to control the gain of the amplifier of the system. The automatic gain control voltage helps to keep the volume of the receiver constant to the level set by the user. So up till now we saw two topics. One is FM demodulator and another is double conversion method in communication receiver. So what you have to do now is you draw this two block diagram a double conversion method of communication receiver and FM demodulator block diagram from internet or from book, from anywhere, and you FM receiver block diagram and this double conversion method communication receiver block diagram need to be remembered by you. You draw it in your notebook, make a PDF of these two block diagrams and upload it to the assignment I have already created for you. So do this and I will grade you. You have to use pencil, eraser and scale, draw it properly and submit it to me. Just block diagram you have to draw, you don't have to write anything else. So draw it and submit it to me. Okay, I have also uploaded a PPT of this chapter to the file section or to the poster section. You can go and refer the PPT. There is a slide number 59 where FM receiver block diagram is there. You can draw FM receiver block diagram from that also, and there is a slide number 72 where the block diagram of communication receiver is there. You can draw it from there also. So draw it and submit it to me. And here I am concluding the lecture, and we will see next topics in next lecture. Thank you.